We've got a great night for you. This is called Graphing Functions Using Tables. And this is a common theme on the AP. You'll hear a lot about tabular, or the word table. So take great notes and enjoy. So we're going to be working with a lot of graphing, and here are our tools for graphing. All right, I want you to pause, get this in your notebook. All right, this is kind of your little cheat sheet. And let's talk about each one. X and Y intercepts. Okay, pretty basic algebra idea. If you have an x-intercept, the y value equals 0. If you have a y-intercept, the x value equals 0. All right, make your own little notes. Domain is the x values, range is the y values. Symmetry. You're always substituting in negative x, and it just depends what you get in the end. If you get f of x, you are even. If you get negative f of x, you are odd. Okay, keep those in mind. Discontinuities, holes and vertical asymptotes. You get a hole if things cancel. You get a vertical asymptote when you set the denominator equal to 0. Limits at infinity get you horizontal asymptotes. That was big on our spiral last week. Relative extrema. Anytime you want a max, a min, increasing, decreasing, you're looking at that first derivative. And that kind of ties in 6 and 7. Points of inflection, concavity, all deal with the second derivative. Okay, types of intervals we should be pretty familiar with. Notice I have slopes are positive, so that tells me that my function is increasing. And my second derivative negative, which tells me that my function is concave down. So think about what you want to look like. Increasing is going up. I can be concave down and going up, or concave up and going up. Make sure you are concave down and increasing. In this example, my slopes are negative, so my function is decreasing, and I am concave down. So you want to be decreasing, so you're going down. Now just be concave down versus concave up. Next example, f prime is less than 0, so I'm decreasing. F double prime is greater than 0, so I'm concave up. So decreasing is going down, and just be concave up. And then you'll notice I am, f prime is greater than 0, so I am increasing. F double prime is greater than 0, so I'm concave up. So picture yourself as going up. Now make it concave up. Now, one of my favorite things to do is actually sketch out these graphs. And I think it's quite easy, and it's a little enjoyable as well. So I want you to pause it, and let's go ahead and sketch out a nice graph. Take up a good half a sheet of paper here. And we have to be very, very particular. You never know who's going to be grading your exam, and it's got to be very, very clear to the grader, you know, the concavity, whether your function's increasing or decreasing, what point it's at. So the one thing they tell us is that our function is continuous from negative to positive infinity. So that's telling me I should not have any holes in my graph. I shouldn't have to pick up my pencil at all. I should have a nice smooth curve. Now, I clearly see some points. I know when x is negative 4, the y value is 5. So I immediately go and plot that point. When x is negative 4, the y value is 5. When x is 0, the y value is 0. When x is 2, the y value is negative 3. And when x is 5, the y value is 0. Okay, those are the only points I know for sure. All right, now the other ones are just going to be kind of estimates, but those points have to be plotted for sure. Now, let's talk about what f prime talks about. Okay, f prime talks about my slopes, and that tells me whether my function is increasing or decreasing. Okay, that tells me whether my function is increasing or decreasing. So I'm going to make some notes. From when I'm less than negative 4, I should be increasing. Then in this section, I should be decreasing. This section, I should be decreasing. This section, I should be increasing. And in this section, I should be increasing. And I go through that and put that on my table. The next thing I say to myself is, well, when I go to make my sign charts, I always set the derivative equal to 0. Those are my critical points, when the derivative equals 0 and when the derivative does not exist. Do I have any of those? Right off the bat, I see one that doesn't exist. If the derivative doesn't exist, remember that's coming to either a corner or a cusp. Okay, so keep that in mind. Here it's equal to 0. Okay, if I have a slope of 0, I want to make sure that's horizontal. Okay, I have a slope of 0. And those are the two that only stick out to me. So I know I have some sort of corner or cusp, and I know I have a nice horizontal slope there. Now let's talk second derivative. What does f double prime talk about? Well, f double prime, remember, describes your concavity. So I make some notes to myself. If I'm positive, I'm concave up. This section should be concave down. Here's concave up, concave up, concave down. All right, so I make a lot of marks before I dare even draw out what I think is happening. The last thing I ask myself is, do I have any points of inflection? And remember, a point of inflection happens when f double prime changes signs. All right, so let's look at f double prime. Do I change signs? I have to grab a different color here. Well, f double prime went from positive to negative. So let's be clear, there's a point of inflection. Then I went from negative to positive, so I have another point of inflection. Positive to positive is nothing, and positive to negative, there's another point of inflection. Okay, so you have to consider all of these things as you sketch out the graph. So it's probably easier to do in pencil and then go back and fix anything you need to. So I'm going to start in this section particularly. Okay, up until -4, I need to draw something that's increasing and concave up, and positive means I'm above the x-axis. Okay, I have positive y values, I'm above the x-axis, I'm increasing and concave up. So I kind of sketch it out in my head first. So I know I have to be going up. Okay, I can't be a straight line because that's not concave up. If I went like this, I'd be concave down. I have to go up like this. So I can draw my first piece in. I know I'm increasing, so don't go above the or below the x-axis. I'm increasing, concave up. Does that look up like a cup? Okay, keep that in mind. All right, when I get to -4, I have to reach a height of 5. I don't exist, so I'm coming to a cusp. And I should be a point of inflection, so I should change from concave up to concave down. Okay, so keep in mind I want to see a corner there. All right, between -4 and 0, between these 2 points, you have positive y values, so you're above the x-axis. You're decreasing, it makes sense you're going down. Now don't draw a straight line. You are concave down. So do I want to look like this, or do I want to look like this? Remember, I want to be concave down. I'm thinking it's going to look like this. And you know, that doesn't even have a great bend to it, but make sure it looks concave down. So notice I have a nice point. Okay, it's a cusp, and I'm concave down. All right, when I hit 0, my y value should be 0. I should have a negative slope. And notice I'm a point of inflection. So I should change from concave down to now becoming concave up in this section. All right, so in this section, my y values are negative, so I'm below the x-axis. I'm decreasing, so I'm going down. And just make sure you draw something that's concave up. So do you want to go this way or this way? Hopefully you're saying more like that. All right, between 2 and 3, or 2 and 5, your negative y values, you're below the x-axis, increasing, so you should be going up. Now just watch your concavity. Do you want to be down like a frown or up like a cup? I think we want to be up like a cup. Make sure we're positive. When I get to 5, notice that's a point of inflection. I change signs. I have positive y values. I should be above the x-axis, increasing, go up, and be concave down. So I would say again, do I want to be like this or like this? Concave down would look like this. And so this is what my function should look like. Now again, it's probably best to do in pencil and just take your time and go back and fix whatever you need. And always check yourself, check this section out. I see positive slopes, concave up. Go back. Were you positive slopes and concave up? Yes. In this section, I see negative slopes and concave down. Slopes are negative, concave down, above the x-axis. And just check them as you go through. All right, now just for fun, let's answer some questions without looking at the graph that you should be able to get just from looking at this table. All right, so letter A. When if I said, when do we have a relative max? Okay, just by looking at this table, you should be able to come up with it. Now, my biggest suggestion is to start with the justification. How would you describe a relative max? We should all know that happens when f prime changes from, picture a max. How do you get a max? You have to go from positive to negative. All right, so again, I start with the justification. When f prime changes from positive to negative. Now I go and I look at f prime. Is there any time where we change from positive to negative? Well, I have positive to negative. Well, that must be an answer. X equals -4. Does it happen again? Positive to negative? I would say no. Part B. Is there any time where you have a relative min? Okay, well, think about your justification. I have a relative min when f prime changes from negative to positive. All right, look at f prime. Do you ever see it changing from negative to positive? Well, we had positive to negative, negative to negative, negative to positive. So at x equals 2, I must have a relative min. And again, I'm just using my justification. How about points of inflection? Okay, do we have any points of inflection? Well, again, start with the justification. I have a point of inflection when f double prime changes signs. So this time, go look at f double prime. Does f double prime change signs? Well, it went from positive to negative. There's 1. So what was that? X equals -4. I went from, let's see, negative to positive. So there's another one. That's x equals 0. Positive to positive, that's nothing. But positive to negative, there's another one. So I have one at 0 and at 5. Okay, so you should be able to read the table and get all this information just as easily. Now, I can't stress enough, I did my justification first, then I came up with the answers. All right, so let f be a continuous function on the closed interval 0 to 3 that has the following signs and values as the table below. Part A, state any relative extrema. So again, I can't stress, start with your justification. How do you find relative extrema? Well, you find your critical points and you make a sign chart. All right, so my critical points are when the derivative equals 0 and when the derivative does not exist. All right, so this is beautiful. They basically made a sign chart for you. Just look at the derivative. Here's my f prime, here's my f. Give me a critical point. When does the derivative equal 0 or when does the derivative not exist? Well, the first time the derivative equals 0 looks like right here, so it looks like 1 is a critical point. The next time it equals 0 or doesn't exist looks like right here, so it looks like 2 is a critical point. And just be careful, notice they said we are going from 0 to 3. Now, you don't even have to guess, they tell you. Between 0 and 1, you should be putting a plus sign. Between 1 and 2, you should have a negative. And between 2 and 3, you should also have a negative. Okay, so now let's talk about our relative extrema. What does that tell me? That tells me at x equals 1 is a relative max. And of course I know that because f prime changed from positive to negative. Okay, there's my justification. Is x equals 2 anything? Well, no, because f prime went from negative to negative, so it is not a relative max nor a relative min. B says state any points of inflection. So again, start with your justification. When do you have a point of inflection? Well, that's when f double prime changes signs. All right, so this is nothing fancy. They made a table for you. Go to f double prime and just follow the signs. When does it change signs? Well, I went from negative to negative to negative. Does f double prime change signs? I would say no. So I just want to be clear that we have no points of inflection. And my justification is f double prime does not change signs. Okay. Part C, let's sketch this function. All right, so part C, we're just going to say sketch. So I've rewritten my table here for you, and we're going to sketch this function. Now we have a nice domain, so let's get a nice window set up. They told us the x values go from 0 to 3. So I have a 1, 2, and a 3. And if I look at my y values, okay, which of course is right here, if I follow my y, I clearly at 0 have the point 0 plotted. At 1, my y value is 2. At 2, my y value is 0. And at 3, it says my y value is negative 2. Alright, so now let's just be careful. Between 0 and 1, your y values are positive. So that means you are above the x-axis. Okay, your slope is positive. Okay, and that tells me that my function is increasing. My second derivative is negative, which tells me I'm concave down. So, use your pencil. You have to be increasing, so you're going up, but you need to be down like a frown. So I would say that looks something like that. When I get to 1, my slope is 0, so that means it should flatten out. Okay, and my second derivative is negative. So keep that down. I should be concave down. That's what it's telling me, concave down. All right, between 1 and 2. My y values are positive, so I'm above the x-axis. My slopes are negative, which tells me my function is decreasing. And my second derivative is negative, which tells me I'm concave down. Okay, so again, I had a 0 slope there, concave down. When I get to 2, okay, my derivative does not exist. What does that mean I'm coming to? All right, so hopefully you're saying you have some sort of point or cusp there. Your derivative does not exist. Between 2 and 3, I'm negative, so I'm below the x-axis. Okay, keep that in mind, below the x-axis. My slopes are negative, which tell me I'm decreasing. My second derivative is negative, which tells me I'm concave down. So I need to be going from here to here, and I need to be concave down. Now remember, it says your derivative doesn't exist, so when I do this, notice that comes to a nice cusp there, and that's what it says. My derivative does not exist there. And I'm decreasing and concave down. So I would say that picture looks pretty fantastic. I can go back and check. I should be positive and concave down, which I am. I should be decreasing and concave down, which I am. Doesn't exist. And then decreasing and concave down. All right, our last question for the night deals with the absolute extrema. Okay, so I want to know when this function has an absolute max and absolute min. Now remember, absolute is the closed interval test. Okay, and this is the one and only time we plug things back into the original. So because it's the closed interval test, I have to use the endpoints of 0 and 3, and I have to use any critical points. Now remember, we already know our critical points from this table. A critical point is when the derivative equals 0 and does not exist. So look at this row with the derivative. How many times does it hit 0 or does not exist? My first critical point here, it hits 0 is 1, and then it doesn't exist at 2. Now both of those fall within the closed interval, so I have to use 1 and 2. Now remember, I'm plugging them into the original. At 0, I knew my function was 0. At 3, I knew my function was negative 2. Whoops. So at 0, I was at 0. At 3, I was at negative 2. At 1, let's see, at 1 I was at 2, and at 2 I was at 0. So I can say I have an absolute max, let's see, of 2, and that happens at x equals 1. And I have an absolute min of negative 2, and that happens at x equals 3. Well, I think that does it for us tonight. I look forward to some great practice tomorrow, and have a great night.